and federal, state agencies, and local communities to protect and restore the health of Lake Erie, one of our most vital natural resources. Today, I'll be sharing insights from Ohio's Domestic Action Plan, our roadmap for reducing nutrient pollution, and how we're using nutrient monitoring data to guide and evaluate our progress in the fight against harmful algal blooms. Lake Erie is a very important resource for recreation, for wildlife, the economy, and drinking water. Under the Great Lakes Water Quality Agreement, Annex 4, goals have been set to protect Lake Erie. These are the Annex 4 goals as ecosystem objectives: reducing harmful algal blooms in the Western Basin and increasing oxygen in the Central Basin. These objectives have been translated into pounds or metric tons of nutrient loads to be reduced. I'm going to update you on what the state of Ohio and its partners have been doing to reduce these nutrient loads, how we have been monitoring progress, and what actions are being taken to continue making progress towards these goals. What is the Ohio Domestic Action Plan? This plan is Ohio's response to a broader commitment under the Great Lakes Water Quality Agreement, which calls on states and provinces to reduce phosphorus entering Lake Erie, a key driver of harmful algal blooms. The plan is a collaborative effort led by the Ohio Lake Erie Commission in partnership with Ohio agencies like Ohio EPA, Department of Agriculture, Department of Natural Resources, and Department of Health. It outlines a comprehensive strategy to reduce nutrient pollution, especially from the Maumee River watershed, which is the largest contributor of phosphorus to the lake's western basin. The plan supports and aligns with Governor DeWine's H2 Ohio initiative, which provides funding and coordination for on-the-ground projects like wetland restoration, agricultural best practices, and home sewage treatment upgrades. In short, the plan is Ohio's blueprint for protecting Lake Erie's water quality, grounded in science, built on partnerships, and focused on measurable results. Let's take a look at the status of the resource as we see it from the monitoring programs. To understand the status of harmful algal blooms and nutrient levels in Lake Erie and its tributaries, we first need to talk about flow. That is, how much water is moving through the system. Rainfall and river discharge are major drivers of nutrient loads. In years with more rain, more phosphorus is washed off the land and into the lake. In drier years, we typically see lower loads. In 2025, the flow was about average compared to recent years, but it was still 22% lower than the flow we saw in 2008, which was a particularly wet year. That's the year that was chosen as the baseline value for Annex 4's target setting. Because of the lower flow, we expected lower phosphorus loads in 2025, not necessarily because of management actions alone, but simply due to less water moving through the system. It's important to note that there's no perfect way to separate the effects of rainfall from the effects of our nutrient reductions. That's why we look at both load, the total amount of phosphorus, and concentration, how much phosphorus is in each unit of water. Together, these indicators help us understand whether we're making progress and where we still need to focus our efforts. So just keep this point in mind as I discuss the monitoring results next. Here we're looking at lake monitoring. On the left is the remote sensing of the harmful algal bloom, which is analyzed and produced by NOAA, the National Oceanic and Atmospheric Administration. We don't have the final severity analysis for 2025 from NOAA yet, but maximum bloom severity was approximately between August 22nd and the 30th in 2025. The bloom season was declared over by NOAA on November 19th, 2025. And on the right, we see the results of a model that NOAA has developed that displays temperature and oxygen levels in the lower parts of Lake Erie. The very small circles are monitoring stations on buoys that help guide the model. A low oxygen zone at the bottom of the lake is in fact normal and expected. In this case, we're trying to limit its extent and severity. In 2025, the greatest extent of low oxygen levels in Lake Erie occurred in late September. I mentioned the Annex 4 goals earlier. The subcommittee of federal, international, and state partners that guides the fight against harmful algal blooms is working on ways to quantify the extent, duration, and severity of this low oxygen zone so that year-by-year comparisons can be made. So for now, we can't make that comparison. And if you go to NOAA's website, if you search for they call it hypoxia, if you search for the hypoxia forecast, you can see this as a little bit of a movie. Now let's look at how nutrient loads and harmful algal blooms have changed over time. One key point of monitoring in the tributaries is the USGS gauge station on the Maumee River at Waterville. The two charts on the left are from this station. The red and yellow lines indicate the spring target loads for this station. The yellow is a 20% reduction from 2008, and the red is the 40% reduction from 2008. And this goes from the year 2000 up through 2025. Dissolved reactive phosphorus is in the chart at the top, and total phosphorus is at the bottom. Dissolved reactive phosphorus is the form of phosphorus most readily available to algae, and you can see that its trend is heading downward since 2015, which is encouraging. Total phosphorus, however, has remained mostly flat, meaning that while we're reducing the most problematic form, the overall phosphorus entering the lake hasn't changed much. On the right, the larger chart shows the harmful algal bloom severity index. Since 2015, severity has improved somewhat. However, it is still only about halfway to the objective, which is indicated by the grayed out part at the bottom of the chart. Remember what we discussed on the previous slide, flow matters. Years with lower river discharge, like 2025, tend to have lower loads simply because less water is moving through the system. That means some of these improvements are influenced by weather patterns, not just management actions. However, new methods are being used to look at trends that try to remove the effect of the flow. The figure on the left is the same dissolved reactive phosphorus load chart from the previous slide. But the figure on the right uses something called the weighted regression of time, discharge, and season, or WRTDS. This is a complex mathematical model that attempts to remove the variability due to flow. It suggests that there are other factors contributing to the decline in dissolved reactive phosphorus loads. The model is not set up to test or determine what this other factor or factors is, but it does suggest that management actions for dissolved reactive phosphorus may be having some effect, as we do see a little bit of a decline. And this is suggestive of a decline of about 6 to 10% from the levels that we saw in 2008. That is a decline outside of flow fluctuations. We also use concentration values to try to control for the influence of flow. This kind of a flow-weighted mean concentration, it represents the total load as it is measured dissolved in the flow of the Maumee River at Waterville. Think of it as like sugar and coffee. Concentration is the sweetness factor in the liquid. This method does not control for the variability due to flow quite as well as the WRTDS, but it's not as complex to calculate and it's easier to report. The results are consistent with load trends. Here I do have the data point for 2025. It is very encouraging that the dissolved reactive phosphorus concentrations are trending down and that we have, in fact, in 25 saw the lowest value that we've had in quite a long time. And again, total phosphorus here, the flow-weighted mean concentrations for total phosphorus have not been changing very much. I focused so far on the lake and the main Maumee River station, but let me talk a little bit about how this maps out across the Lake Erie watershed in Ohio. This figure is from the 2024 Water Monitoring Summary, which is available on the lakeerie.ohio.gov website under the Planning and Priorities tab. This is a subset, just a few of our monitoring sites, both across the shoreline and within the Maumee River. There is an extended monitoring report that's available on the website for the Domestic Action Plan. On this chart, the circles indicate the total phosphorus load amounts, and the triangles indicate the dissolved reactive phosphorus concentrations. And you can see that the upper Maumee watershed, kind of to the left of the figure, the loads are lower because the area drained is smaller. Some of these are much smaller subwatersheds, but the concentrations are higher because there's less water to dilute the nutrient runoff. Light circles with green triangles are areas where both loads and concentrations are low. For example, the Cuyahoga River has a low load and a low concentration, and so that area, while it does receive attention for water quality cleanups and water quality protection efforts, it has not been the focus in the Ohio Domestic Action Plan. But this figure also illustrates why portions of the Maumee watershed, which has a high density of agricultural use, is of primary concern for our actions. Most of these stations in the Maumee River have high loads and or high concentrations. I'd also like to mention that there's going to be some changes in our data reporting going into the future. We now have enough data to tweak which locations are monitored, and recent cost cutting at both the state and federal levels means that some changes are being made for the stations monitored. We're also working towards an interactive portal for these data, and it will likely complement the efforts of USGS, which is also developing interactive data portals for their monitoring data. Hopefully in the next year or so, it will be easier to access the data in visual format more directly over the internet. Next, let's look in more detail about actions being taken to protect the resource. In the 2023 update of Ohio's Domestic Action Plan, we focused on 4 main areas of action. First, we know from Ohio EPA's nutrient mass balance analyses that most of the nutrients entering Lake Erie come from agricultural lands. So that's where we're concentrating much of our effort, helping farmers adopt practices that keep nutrients on the field and out of the water. Second, we're working to restore wetlands in key watersheds. Wetlands act like natural filters, trapping nutrients before they reach streams and rivers. Third, we're supporting local communities by providing funds and support to help counties with fixing failing home sewage treatment systems, which can also contribute to nutrient pollution. And finally, we're doing watershed planning at multiple scales, from large regional plans to very local plans for smaller areas. This helps us tap local knowledge to put the right projects in the right places for the biggest impact. We have additional actions that have also been underway. Most significantly, the Maumee Watershed Nutrient TMDL, or Total Maximum Daily Load, which will address phosphorus reductions in the Maumee River. That is a Clean Water Act, federally driven program that the state administers. We also included a number of support actions, such as research and monitoring. And earlier this year, we updated our list of partners who are actively working on nutrient reductions across Ohio and the list of actions being taken by these partners. That information is available on the Ohio Domestic Action Plan website. The next sets of slides about actions for H2 Ohio I have taken from the H2 Ohio annual report for 2025, which is now available on the on their website, which is h2.ohio.gov. So if you would like to read all about it, there's an extensive amount of detail about all of these actions in that report. But in the next several slides, I'm going to kind of hit some high points for you. This slide shows the impact of the work being done by the Ohio Department of Agriculture through the H2 Ohio program from the beginning. So first, take a look at the numbers. ODA has 3,200 agreements with farmers, representing a strong commitment to implementing best practices on the ground. These agreements cover 2.2 million acres of farmland where practices like cover crops and nutrient management are reducing runoff. The vast majority of that acreage is in the Lake Erie watershed, although there have been a few projects now in other parts of the state. Conservation ditches have been added, which help slow water and trap nutrients before they reach streams. And importantly, ODA is working with many retailers and crop consultants who play a key role in advising farmers and ensuring these practices are adopted effectively. On the right, you'll see a bar chart showing estimated nutrient load source reductions from these efforts. These source reductions represent real progress towards meeting our phosphorus reduction targets for Lake Erie. And the takeaway here, these numbers show that collaboration with the agricultural community is making a measurable difference. And again, all of these numbers are in the H2 Ohio annual report. So if you're following along, you could just go back to that report and get all of this information. This slide highlights the progress made by the Ohio Department of Natural Resources through the H2 Ohio program, again, from the beginning. Hundreds of wetlands projects have been launched, and many have already been completed, restoring natural infrastructure that filters nutrients before they reach Lake Erie. These projects represent significant funding investments and involve multiple partners, including local governments, conservation groups, and private landowners. In total, ODNR has restored thousands of acres of wetlands, both in the Lake Erie watershed and across the state, creating habitat for wildlife and improving water quality. On the right is an example of a project in the Lake Erie watershed. This is the Thoreau Nature Preserve. This project restores 250 acres within the Buckskin Creek Tiffin River watershed, and this project will reduce sedimentation and nutrient loading while creating educational opportunities for the public to explore and learn about wetlands. And the collaborator is the Acres Land Trust. It was a 250-acre restoration with a phosphorus reduction of approximately 186.9 pounds per year. Each project for ODNR now has an associated source load reduction based on work funded by H2 Ohio to refine these estimates. And the takeaway here is that ODNR's work is turning plans into real measurable improvements on the landscape. This slide highlights the work Ohio EPA did in 2025 to improve wastewater infrastructure and reduce nutrient impacts. Over a dozen projects were funded in this past year across the state, helping communities upgrade critical systems. These projects represent millions of dollars in investment, ensuring long-term improvements in water quality. Thousands of homes have been connected to centralized wastewater treatment or otherwise improved, reducing the risk of untreated sewage entering waterways. And Ohio EPA is working with multiple communities from small townships to larger cities to make these improvements happen. On the right here, you'll see two examples. In the city of Findlay, a sewer pipe repair project in a subdivision is preventing leaks and improving system reliability. In Ravenna Township, funding is helping connect additional homes to the wastewater treatment plant, eliminating failing septic systems. These projects may not be as visible as wetlands or farm fields, but they play a critical role in protecting water quality and public health. Education and research are ongoing and remain a critical part of Ohio's strategy to reduce harmful algal blooms. On the education side, we're continuing webinars, in-person meetings, and online resources, along with regular social media updates, including at the federal level, to keep stakeholders and the public informed. On the research side, we're focused on understanding how phosphorus moves and is retained in soils and waterways, which helps us target solutions more effectively. The next round of HABRI, the Harmful Algal Bloom Research Initiative, which is a state-level funding source run through the Ohio Department of Education, Ohio Department of Higher Education, is already underway, funding projects that address key science questions submitted by the state agencies to support science-based decision-making. If you'd like to dive deeper into the results of this research, you can visit the Ohio Sea Grant HABRI page, where reports from past projects are available to the public. And these are very much reports that are written to be informative to the public, so you should find that they have done a good job of translating what could be complex science into a more clear and understandable format. Education and research together ensure that our actions are guided by the best science and that communities stay engaged in protecting Lake Erie. Before we talk about challenges, let's take a moment to recognize the progress that's happening. We're starting to see signs of ecosystem response, which means that the actions we've taken are beginning to make a difference. Many projects are underway or completed, and you can see this reflected in the March 2025 summary of Ohio Domestic Action Plan actions, as well as in the biennial reporting for the Maumee River Watershed Nutrient TMDL and the annual H2O Ohio reports. Progress isn't uniform. It varies by region and by action type, but the overall trend is positive. A big driver of this progress has been H2O Ohio, which has led to significant actions in the Maumee and Sandusky River watersheds, two of the most critical areas for nutrient reduction. Of course, we still need coordination, funding, and adaptive management to keep this momentum going, but the signs are clear. Ohio's efforts are making a measurable impact. This slide highlights some of the key challenges and opportunities we face. First, higher temperatures and more frequent extreme rainfall events are changing water dynamics, making nutrient management more complex. Second, we're dealing with legacy phosphorus, the residual phosphorus that's stored in the soils and sediments over decades, which continues to move into waterways even if fertilizer use is reduced. And third, we need long-term funding and monitoring to sustain progress and measure results over time. On the opportunities side, we have new technologies being evaluated through Ohio's Technology Assessment Program, which is now open for the next round. We're also expanding community engagement with plans for an in-person Ohio Domestic Action Plan workshop next year in 2026, and continuing strong federal partnerships through programs like the Great Lakes Restoration Initiative. The images on this slide tell an important story. The inset photo shows a severe bloom in the Maumee River near Defiance back in 2016, while the background photo from 2024 shows the same location with a bloom that's smaller but still visible. This illustrates both the progress we've made and the work that remains. Looking ahead, we're currently in what we call the action phase of adaptive management. This means we're focused on putting plans into practice and learning from what works. Right now, our biggest priorities are the implementation of H2 Ohio projects, such as wetland restoration and agricultural best practices, and the Maumee River TMDL program, which sets nutrient reduction targets for one of Lake Erie's most critical watersheds. We're also continuing public education and outreach, including events like this one, because informed communities are essential for long-term success. Ultimately, this work is building towards the next update of the Ohio Domestic Action Plan, which is scheduled for 2028. That update will incorporate new monitoring data, lessons learned from current projects, and stakeholder input to keep us on track towards meeting Lake Erie's water quality goals. Here's the big picture. Ohio is making measurable progress. We've seen reductions in dissolved reactive phosphorus and improvements in harmful algal bloom severity compared to 2015. Programs like H2 Ohio and the Ohio Domestic Action Plan have helped implement wetlands, agricultural best practices, and wastewater upgrades. But challenges remain. Total phosphorus loads are still a bit flat, and most years exceed the targets we've set for Lake Erie. Weather variability and legacy phosphorus in soils make this a long-term effort. And that's why collaboration is key across federal, international, and state agencies, local governments, farmers, researchers, and community organizations. No single group can solve this alone. And finally, everyone has a role in protecting Lake Erie, whether it's supporting conservation programs, reducing fertilizer use, or simply staying informed and engaged. Together, we can make a difference. Thank you for joining me today and for your interest in protecting Lake Erie. If you'd like to stay connected, you can follow the Ohio Lake Erie Commission on social media. Our handles are listed here, and feel free to reach out to me directly at the email on the slide. And one last note, you'll see 4 license plate designs here. When you choose one of these plates, the revenue goes directly to support projects that improve Lake Erie's health. It's a simple way to make a big difference. This year, we have introduced our new kayak Life on Lake Erie license plate, so you could be one of the few and the proud early adopters of our new Lake Erie license plate. Or we appreciate if you have had our Marblehead Lighthouse plate, or the Lake Erie Life Ring plate, or the Toledo Harbor plate. Thank you again, and I'm happy to take questions.
It looks like we have a couple in the chat. Can you see that, Sandra, or do you want me to read it?
I can see that. All right.
Caitlin,
okay.
This is Jen. I'm sorry to interrupt. Do we want to read the questions for anybody that can't see them, or do we want to just, Sandra, maybe you could like either read it or restate it if you would.
Yeah, I'll go ahead and
you're addressing.
Sure. So we have a question. Where are the stats for which BMPs reduce phosphorus the most, and why is there no targeting for areas with most phosphorus discharge? I'm going to start with that part 1 first. We are working on developing that information. The problem with information for which BMPs reduce phosphorus the most is that there's so many variables. There's variables for soil type. There's variables for how much water is being moved. Some of the research is done in states outside of Ohio. We have relied on Kevin King at the USDA Agricultural Research Service. He has given us some information. We have other information on that comes from NRCS and the 590 standard. So some of that information is available in other areas. And I think that, that we haven't published it ourselves because we're not it's more of a science-based research. So we rely on getting our information from the scientific literature for those values, but there's a lot of variability in it. So it's very difficult to take, a study that was done on a particular field or even a particular subset of fields and then extrapolate that and say that any one thing is going to be the best way to do it. We did do a project under H2 Ohio with the commission that was run through the Ohio State University, and I believe the information is available from them, where they evaluated the projects, the BMPs that H2 Ohio is funding on a watershed-wide scale for the Maumee River. And while they were able to conclude that the practices were directionally correct, they were not really able to quantify exactly how much load reduction was coming from each of those practices. So statistically speaking, we know we're doing the right things, and not everything is applicable in every possible place, right? So, for some farmers, certain types of practices just won't fit. If you have a phosphorus filter you want to put in, but the farm field drains in 5 different directions, then that's not really going to be an efficient way of addressing that field. And so in order to maintain the maximum ability of farmers to adapt, to the maximum ability of our consultants, whether that's the Soil and Waters or a private consultant, to find the best fit for the field, we've been emphasizing people participating in the program, doing those voluntary management plans, and then finding the best fit for them. And again, as far as targeting, I think if you're thinking of it in terms of prioritizing locations, what we have been able to figure out is that most of the area is not leaching out a very large amount of phosphorus. And there are a few places that do have a little bit higher phosphorus runoff, but they're generally very localized. It may even be a subset of a field. So it's really difficult to find those places. And so it really is not very efficient to try to go find the very highest phosphorus field or phosphorus section of the field. It's much easier and still having an effect to go with farmers who are willing to adopt practices at a broad scale. They're going to catch those places that are high, even if they catch a bunch of moderate places. And we think that is the most efficient way to deliver these programs. Second part of that question, how are the massive increases in confined animal and land applied manure with phosphorus discharge being factored in this analysis? The Maumee Waterville gauge is summarizing everything that is being discharged into the waterways. Whatever the runoff is, all of it is integrated into that monitoring point. And that's one of the reasons why the state of Ohio has been very focused on making that a key monitoring point. But as you could see in that map, we do have monitoring stations across the Maumee watershed. And now that we've had about 10 years or so of data from most of those smaller locations, we are starting to look at what that means. We need a longer time frame in order to do the regression analysis. In order to have it be meaningful, it needs enough data on how much variability there is from year to year in order for us to get good information. So I think we are going to be in the process of doing much more analysis on those smaller up in the watershed stations to maybe start looking at where in the watershed there might be a little bit more runoff. And if there is enough difference in some of the watersheds where some of those facilities are coming in, then that will begin to give us a scientific basis to decide whether we need additional practices or how we want to handle that. Distinguishing between commercial fertilizer and manure. I do believe that ODA has done a fair amount of work. I know this was discussed in the TMDL, and ODA has produced additional information since that time, looking at commercial fertilizer in terms of what the sales are and manure in terms of what the animals are. We're not able to measure the difference between those two in the water itself, but we can look at it in terms of source loadings. And I know that ODA has been doing some of that work. Let's see. I think that's all of the questions that were in the chat now. Are there any other questions? I see Jen has commented, Defiance has installed 2 phosphorus filters on city-owned land. So that's good. Yeah, definitely need to continue to do the research to figure out whether these are things that are cost-effective and appropriate. On one of the loading graphs, it looks like in the 90s there was a sharp decline in DRP. According to the graph, oops, can't read it. According to the graph, and then it started increasing in the 2000s. Do you know why that happened? Was it sampling efforts, lack of data, or something else? Well, you know, I don't think that the scientists have decided that there's a particular smoking gun. I know that Kevin King wrote a paper some years back and listed out every possible factor that could have been something that was influencing it. And it was like over 20 different ways that farming practices had changed and weather patterns had changed and soil chemistry had changed, that it, you know, it's really difficult to be certain. And a lot of these, we don't really have it very well quantified, some of those things. So it was difficult to construct a regression model that might be able to test out which of those factors might have had an influence. So things like changes in tile drainage. If you have more tile drainage, then it's possible that there's more nutrient loss happening through those tiles, because again, it's improving the drainage, improving the flow, shooting the water out faster and in larger quantities. It may have been changes in tilling practices, with temperatures tending to get warmer, there's more water in the atmosphere, so the rain events have been getting stronger, and you know, a whole host of other factors. It's just not been, nobody has really done any kind of statistical modeling of that to tell us exactly which factor it was that was causing that. But those are some of the things that were changing that we suspect may have contributed to that. Other questions? Okay, here's another one. Chesapeake Bay Committee tracks practices and reductions to achieve 40% reduction, same as needed for Lake Erie. Well, we're tracking that. And, you know, I think in this sense, we may be a little bit hampered by some of the turbulence at the federal level, because I think the ideal was for US EPA as party to the Great Lakes Water Quality Agreement with Canada and the Canadian Water Agency to kind of compile what's all's happening on the US side of the border. So Indiana has their action plan and they're tracking their actions. Ohio, we have our plan and we're tracking our actions, and so on. Michigan has their domestic action plan and they're doing their tracking. And, you know, we would really like to see the federal domestic action plan try to pull all of that together, at least put it all in one place so that it will be easier to see. But again, we have not seen an update to the U.S. domestic action plan recently, so it's been a little bit more difficult to manifest that. I think that one big difference between the Chesapeake Bay program and what we do in our work here on Lake Erie is that with the Bay program being structured within the United States and being closer together, they're able to commit a certain degree of communication resources. And I think that has made it easier to get information from them. In our governance for Lake Erie. We're much more distributed and everyone is farther apart. We have a much larger watershed, many more things going on. It's been a little bit more difficult to compile it. I hope that we can see some more of that coming from the federal level, but I guess we'll just have to see.
Thank you, Sandra. This was really informative. Are there other questions or comments? I know some of you personally, and I know this was thinking about questions or conversations. Thanks, Dr. Zeller. So if there are none, I'll bring up a slide just to share some information about our next event in February. And some of you have asked, yes, we are recording this and we will be sharing the link. We'll have it posted on YouTube and we'll be sharing a link soon. Caitlin, do you want to add anything else? I can bring up that other, I'll have to stop talking so I can bring up that other slide.
I don't think I have anything else. Once Jen gets this other slide put up on the screen, you'll see the details for our next speaker series. So you'll be able to keep an eye out in your email or through the newsletter for our next speaker series. Yeah. Yep, there's all that information. So you can put that in your calendar for next year. And if there's nothing else, thank you all for attending today and have a good rest of your day.
Thanks, Caitlin. Thank you, everyone. Yep. Thank you, Sandra.
All righty. Thank you for having me. I really appreciate you guys helping me get the word out anytime.
Yeah, absolutely. We'll send a link to the recording as soon as we have that on YouTube. And then Sandra, if you have any materials that you want us to share or links to anything, we could also put that. We'll send kind of a summary email out. May have some other news items in it as well, but we can put anything that you have to share. We can kind of collect that and put it with the link to the recording. So feel free to send us anything like that you'd like us to share.
Okay.
Okay. Thanks, everyone.
All right. Thanks. Bye.
I'm going to stop the recording and we'll sign off here. Thank you all.